Welcome to the part 6 of our discussion, and in this video what we are going to discuss is all about the self-ionization of water. Okay, so what we're going to discuss is self-ionization of water. A while ago I said that water is a amphiprotic, which means it can act as an acid and at the same time it can act as base. Okay? Yun yung sabi natin sa acid. Take note guys that a pure water, okay, a pure water, no, contains a very small amount of hydronium ion and at the same time hydroxide ion. Okay? So, a pure water contains, no, contains amounts of hydronium ion as well as hydroxide ion. So simply, a water plus another water no, will give you hydronium ion plus hydroxide ion, wherein the water, in this case, no, the one water acts as acid and the one water here acts as a base. Wherein this acid, or this water who acts as acid, gives no, a proton to our base to produce our conjugate acid, which is our hydronium ion, and this is our conjugate base, our hydroxide. Now, in other words, to make it short and to make it clear, a pure water contains hydronium and hydroxide ion. Now take note guys that the equilibrium constant of the ionization of water is denoted as Kw is equals to the concentration of hydronium ion times the concentration of hydroxide ion. Therefore, we can say that constant self-ionization of water is equals to 1.0 times 10, 1.0 times 10 raised to negative 14. As simply as hydronium ion, so I'll write here, hydronium ion daw is equals to no, 1.0 times 10 raised to negative 7, and hydroxide ion is equals to 1.0 times 10 raised to negative 7. Okay? So this is exactly the same reason why water has a pH of 7. Okay? So if we are going to multiply it, Kw is equals to 1.0 times 10 raised to negative 7, and the concentration of our hydroxide is 1.0 times 10 raised to negative 7, then that will be 1.0 times 10 raised to negative 14. The equation for the ionization of water applies not only to pure water but also apply to aqueous solution. Okay? So the hydronium ion of the solution is the hydronium ion and the hydroxide ion in water in a pure water is 1.0 times 10 raised to negative 7. Okay, example. Example, the OH concentration of a solution is 1.0 times 10 raised to negative 4 m. What is the hydronium ion? So we said that hydronium ion times hydroxide ion is equals to 1.0 times 10 raised to negative 14. Okay? Therefore, we are looking for hydronium. So let's represent it as our X. X multiplied to our hydroxide is 1.0 times 10 raised to negative 4 is equals to 1.0 times 10 raised to negative 14. Divide both sides by 1.0 times 10 raised to negative 4. Kainis naman itong mga manok na to. 1.0 times 10 raised to negative 4. Then x will give us 1.0 times 10 raised to negative 10. Therefore, this is the concentration of our hydronium ion in a solution. Another example will be, sensya na ha, maingay talaga itong mga manok na ito. Another example will be if we have daw OH at, okay, hydroxide is 1.0 times 10 raised to negative 12. Okay, what will be our hydronium if hydroxide is 1.0 times 10 raised to negative 12? So again, that will be hydronium times 1.0 times 10 raised to negative 12 is equals to 1.0 times 10 raised to negative 14. So that will be hydronium is equals to 1.0 times 10 raised to negative 14 over 1.0 times 10 raised to negative 12. That will be our hydronium concentration in a solution is 1.0 times 10 raised to negative 2. Okay? So that is the self-ionization of water. Now, I've mentioned a while ago that pH of water is 7. Have you wondered why 7? Bakit nga ba 7 ang pH ng water? So this time, we are going to find out why is the pH of water is 7. Take note guys that pH should be written as small p, capital H, because we say that pH is the negative logarithm of the hydrogen ion, or simply the negative logarithm of the hydronium concentration. No? So, yung pH daw natin is equals to the negative log of our hydronium concentration. Sabi natin, a pH of less than 7 is, ano ba yan? A pH of less than 7, may less than na, may less than pa. No, a pH of less than 7 is what we call acidic. Right? And a pH of greater than 7 is basic. Okay? Basic. Sabi natin, a pure water contains an hydronium concentration of 1.0 times 10 raised to negative 7. Therefore, if we are going to get the negative logarithm of 1.0 times 10 raised to negative 7, to get the pH of water, then it will give us 7. So why are we going to get the negative logarithm of the hydronium ion? Because that is actually the measure of our pH. No? Yun yung purpose. Bakit mo ginagawa yung pH? To get the hydronium, pH is equals to the negative logarithm of the hydronium ion. If we said that a pure water has a 1.0 times 10 raised to negative 7 concentration of hydronium, therefore, the pH will be 7. Sir, paano po yun? Okay, on your calculator, please input negative sign, click or input log, and then 1.0 times 10 raised to negative 7, then it will give you 7, which is your pH. Now, how about for POH? If you still remember, no, during our first discussion or first day, no, I've mentioned that POH is most of the times being disregarded because we are giving on focus lang on pH, which is the concentration of hydrogen ions or simply the concentration of the hydronium ion. If pH is the negative log of hydronium ion, therefore, we can say that POH is the negative log of our hydroxide ion. Ang sabi natin, a pure water contains 1.0 times 10 raised to negative 7, right, of hydroxide. So if we get the negative logarithm of 1.0 times 10 raised to negative 7, therefore, the pOH of our water is 7. Okay, take note, magkabaligtad po ito. Kay pH, kapag mas mababa sa 7, is considered acidic. Kapag mas mataas sa 7, is considered basic. Tapos kapag ang pH is equals to 7, then that is neutral. Now, how about for POH? If POH is less than 7, that is considered as basic. That is considered as less than 7. Yes, that is considered as basic. While if the POH is equals to 7, it's also considered neutral. If the POH is greater than 7, that is acidic. Okay? Therefore, we can say that the pH plus POH is equals to 14, which is the self-ionization of water. No? Which is the self-ionization of water. Sabi natin, a pure water contains hydronium ion, which is equivalent to 1.0 times 10 raised to negative 7, and hydroxide ion, which is equivalent to 1.0 times 10 raised to negative 7. No? Ito yung self-ionization of water. So when we get that, this is 14. Therefore, we can say that pH plus POH is equals to 14. Again, what is the pH of water? 7. No? The pH of water is 7. The POH of water is also 7. Saan po nanggaling itong 7 na to? Negative logarithm of the hydronium concentration, which is 1.0 times 10 raised to negative 7. This one, saan po nanggaling yung POH na 7? Negative log concentration of the hydronium, hydroxide rather. negative logarithm of the hydroxide ion concentration. Okay? So that's the reason why pH of water is 7 and the pOH of water is 7 because it contains 1.0 times 10 raised to negative 7 of hydronium and 1.0 times 10 raised to negative 7 of hydroxide. Okay? So let's have an example. Let's say the hydronium concentration of acetic acid is no. Wag acetic acid. Iba na lang, iba na lang. Yung example sa book. Yeah. Let's say, for example, the hydronium concentration of a detergent is 1.4 times 10 raised to negative 9. Okay, that is the hydronium concentration. The question is, what is the pH? Okay, what is the pH? So definitely we're going to compute it. So negative log 1.4 times 10 raised to negative 9 will give us 8.85. So the pH is 8.85. Now, what is the pOH? So how to get the pOH? That will be pOH is equals to 14 minus 8.85. So that will be 14 minus 8.85 will give us 5.15. This is our pOH. Ang sabi natin, kapag ang pH is less than or mababa sa 7, acidic. Kapag ang pH mataas sa 7, base. Kapag ang pOH mababa sa 7, base. Kapag ang pOH mataas sa 7, acidic. Let's see if this is correct. pH 8.85. Mataas sa 7, base. pOH 5.5. Mababa sa 7, base. So that is how we get the pH and the pOH of our compounds. Another example. This time, given the pH. The pH is 5.3. The question is, what will be the pOH? What will be the hydronium concentration? And what will be the hydroxide concentration? Interestingly, madali lang kapag pOH because that will be 14 minus 5.3, guys. Pasensya na sa manok. 14 minus 5.3 will give us 8.7. pH less than 7, acidic. pOH greater than 7, acidic. Okay. So the question is, how about the hydronium ion and the hydroxide ion concentration? So that will be, please input in your calculator. Okay. Input on your calculator, shift. Pindutin ang shift. Then press log. Negative sign. What is the pH? 5.3. Then input 5.3. It will give you 5. Okay, it will give you 5.01 times 10 raised to negative 6. So that is our hydronium concentration. Again, paano po yun natin nakuha? Shift log negative the pH 5.3 gives us 5.01 times 10 raised to negative 6. Now, how about for our hydroxide? So, basically the same thing. Shift, in your calculator, shift log, okay, shift log negative 8.7 will give us 1.9, that's simply 2. 2 times 10 raised to negative 9. Ngayon, tingnan natin if this is equals to 14. Now, 2.0 times 10 raised to negative 9 multiplied to 5.01 times 10 negative 6. Okay? It should give us 1.0 times 10 raised to negative 14. And if you get the negative logarithm of this one is equals to, I hope you can follow. One more example. Okay, the hydronium concentration is, the hydronium concentration is 3.5 times 10 raised to negative 3. Question, what is the pH, what is the pOH, and what is the hydroxide? So simply the pH will be negative log 3.5 times 10 raised to negative 3 is equals to 2.46. No? The pH is 2.46. So the pOH is 14 minus 2.46 is equals to what? 14 minus 2.46 is equals to 11.54. So 11.54 plus 2.46 is 14. Okay. Now, how about the hydronium concentration? Hydroxide, rather. Meron kang two-way to solve it. Number one, either you get the shift log or antilog, shift log, negative 11.54. It will give you 2.88 times 10 raised to negative 12. Or if you want, we can compute it this way. So 3.5 times 10 raised to negative 3 times OH equals to 1.0 times 10 raised to negative 14. OH, divide both sides, no? 1.0 times 10 raised to negative 14 over 3.5 times 10 raised to negative 3. So please compute. 1.0 times 10 raised to negative 14 divided by 3.5 times 10 raised to negative 3 will give us the same thing. Will give us the same answer, which is 2.88 times 10 raised to negative. Okay? Negative 12. So therefore, let's multiply it. 2.88 times 10 raised to negative 12 times 3.5 times 10 raised to negative 3 will give us 1.00 times 10 raised to negative 14, which is again equivalent to number 14. Okay, so that is how we are going to get the pH, the pOH, and our hydronium as well as our hydroxide concentration. And the last topic that I am going to discuss is all about the Henderson-Hasselbach equation. Okay? Henderson-Hasselbach equation. Wherein, no, it is a mathematical relationship between the pH, the pKa of weak acid, and of course, the concentration of HA and its conjugate acid. It is derived as HA plus or weak acid plus water will give us our A plus our hydronium ion. Okay, so that is basically Ka is equals to our A times our hydronium ion over our HA. Okay? Taking the logarithm, giving us the logarithm, Ka is equals to log of our hydronium ion plus the log of our A over HA. Or simply, no, log Ka is equals to negative log of our hydronium ion, negative log of our A over HA. Bakit po naging negative? Because we multiply this one to negative 1. Negative log of Ka is by definition ay ano? The pKa. Tama? The negative log of Ka is our pKa. And the negative log of hydronium is our pH. Therefore, it is simply as our pKa is equals to the pH minus log A over HA. So this is our Henderson-Hasselbalch equation. Okay? If we are going to arrange it to get the pH, then that will be pH is equals to pKa plus log A over HA. We transpose this to other side. Since we transpose it to other side, instead of having a negative charge, it will become a positive charge. Okay. Example, no? Example po natin. What is the pH? So I will write what is the pH of phosphate buffer solution containing 1.0 mole of sodium phosphate and 0.50 moles or mole of disodium phosphate dissolved enough in enough water to make 1 liter of solution. Okay? So again, our formula is pH is equals to pKa plus log A over HA. So pH is equals to 7.21. Sir, question. Saan po nanggaling yung 7.21? That is the pKa of our phosphate buffer plus log. That will be, ano yung A? Ang A natin is yung disodium phosphate. Ano ang kanyang concentration? 0.5. 0.5 divided by, anong concentration ng ating weak acid? 1.0. So that will be pH is equals to 7.21 plus, so divide it first, 0.50 divided by 1, that's gonna give you 0.50. And then we're going to get the logarithm. Okay, logarithm of 0.5, that is negative 0.30. So we add this. pH is equals to 7.21 plus, since this is a opposite sign, so magiging, instead of having plus sign, it will become negative sign. So 7.21 minus, that's your basic algebra. 7.21 minus 0.30 will give us what? 6.91. So the pH is 6.91. Okay? So that is how are we going to solve our pH using the Henderson Hasselbach equation. So this will be the end of our discussion. I hope you learn in watching these videos. Once again, good day and have a nice day. God bless you all.